In this video, we're going to determine the value of some more trig functions, or some trig functions at more angles using special triangles. And then we're going to do a few examples working with trig functions in a variety of ways. So I first want to talk about two special triangles. So the first one is a 45, 45, 90 triangle. So I'm going to draw a picture here. Hopefully that looks like a 90-degree angle. Okay, so we have a right triangle. I guess I could have drawn it a different way. But 90-degree angle where these two angles both are 45 degrees. Okay, now when you have a triangle where these two angles are equal, we call it an isosceles triangle. Isosceles, something like that. And what happens is that these two sides surrounding the other angle are actually equal. Okay, the other angle doesn't have to be 90 for this to happen, but in our triangle it does. Okay, so the length of those two sides have to be the same. So what we can do is let's just let them be 1. Okay, so if these are both 1, length 1, then this other side, C, has to be this, because it's the hypotenuse, it's across from the right triangle. It has to be square root of 1 squared plus 1 squared, or square root of 2. Okay, so then now, because we have this triangle, we can talk about the trig functions, because remember they're defined on triangles. Okay, so if I want, let's say I use this as my angle. Okay, so this is my theta, it's 45. So sine of 45 degrees, which remember is sine of pi over 4, is going to be the opposite. Okay, so this one is the opposite. This side here is the hypotenuse. Okay, it's across from the angle. And this one over here is going to be the adjacent. So this is going to be the opposite over the hypotenuse. So it's going to be 1 over root 2. Okay, this is actually, if you want to, sometimes they write this, we rationalize the denominator here. So they multiply it by root 2 over root 2. So you might see it written as root 2 over 2. But it's the same as 1 over root 2. Okay, you can write it however you'd like. Cosine of 45 degrees, or cosine of pi by 4 radians, is the adjacent over the hypotenuse, and the adjacent is also 1. So it's also 1 over root 2. And then the tan of 45 degrees, or the tangent of pi by 4, is the opposite over the adjacent, which is 1 over 1 here, so 1. Okay, now remember when we define the trig functions, it doesn't matter that I just chose these to be 1. Okay, the ratios will be the same because all these triangles are going to be similar. So the ratios are always the same. So you'll get the same value for all your trig functions. So you can pick whatever is convenient. Okay, I just picked 1 because it's sort of easy. So then you can find the other 3 by just doing 1 over these 3 trig functions. Okay, so those are the only ones I'm going to talk about. Okay, the next triangle is called a 30, 60, 90 triangle. So I'm going to draw this one upright. Okay, so maybe it looks something like this. So here's our 90. This is our 60 degrees. And this is our 30 degrees. So what I'm going to do for this one is actually double it. Okay, so I'm going to flip it about its height here, so that this is 60 degrees and this is 30 degrees, which means that this is 60 degrees, these two together. So when all these angles are the same, this is called an equilateral triangle. Triangle. Okay. So when all the angles are the same, all the side lengths are the same. Okay, so that's this whole length. So I'm actually going to say that they're all length 2. So the reason I want to do 2 is because this bottom one, then I can do it's 1 and 1. Okay. So I just wanted an even number so that I don't need to use a fraction. But I mean, you can. It doesn't, if you label them 1, these are both 1/2 and 1/2. It doesn't matter. So then this height, let's call it, say, h. Okay. We can compute that using just the purple triangle here. So it's going to be the square root of the hypotenuse squared minus the other side length squared, which is 1. So it's going to be square root of 3. Okay, so we get this triangle. So again, we can compute all of its, so we can actually compute all of the angles for 30 and 60. Okay, so if we're looking at 30 degrees, okay, that's sine of pi by 6. Okay, so that's when we're using, actually maybe I'll write these in a different color so you can tell a bit better. So let's use maybe pink here. Okay, so this is sine of pi by 6. Okay, so here's our angle, which means that the 1 is our opposite, the h is our adjacent, and the 2 is our hypotenuse. So sine is the opposite over the hypotenuse, so it's going to be 1/2. Cosine of 30 degrees, or cosine of pi by 6, is going to be the adjacent over the hypotenuse. So that's going to be root 3 over 2. And tan of 30 degrees, or tan of pi by 6, is going to be the opposite over the adjacent. So it's 1 over root 3. Okay, now I'll use blue. Okay, so now if I want 60 degrees, okay, this is my angle. So that means that the h is now the opposite. Okay, the 1 next to it is actually the adjacent, and the 2 is also still the hypotenuse. Okay, so sine of 60 degrees is sine of pi by 3. So it's going to be the opposite over the hypotenuse. So it's root 3 over 2. Cosine of 60 degrees, or cosine of pi by 3, is the adjacent over the hypotenuse. So here's where we get the 1/2. And tan of 60 degrees, or tan of pi by 3, is going to be the opposite over the adjacent. So it's root 3 over 1, or just root 3. Okay, so it's kind of useful when you're trying to remember these in the future. It's useful to note that the sine and the cosine value, oh, that's big. Okay, anyway, the sine and the cosine values, so if we just look at these two, notice they're the same numbers, but they swap. Okay, so one way that I sometimes try to remember this is on the unit circle. Okay, so let's just draw a picture down here. So if there's my terminal side, when I'm 30 degrees, okay, it looks like that. Okay, but when I'm 60 degrees, it's a bit taller. Okay, so that's 60 degrees. So if I think about where they intersect the unit circle, this isn't very good, but I'm just going to draw sort of half of it. Remember that the coordinates are cos 60, sine 60 for that one. And for this one, it's going to be cos 30, sine 30. So all I need to remember is that root 3 over 2 is bigger than 1/2. Okay, so for these two angles here, so for 60, the cosine is the x value, right? So here's one x value and here's the other x value. So I know that cosine of 30 degrees should be bigger than cosine of 60 degrees. So that tells me that cosine of 30 has to be root 3 over 2, and cosine of 60 has to be the 1/2. Okay, if you go the other way and you think about their heights, this is one y value and here's another. Okay, so I also know that sine of 60 degrees is bigger than sine of 30 degrees, so the y value is taller. So that means that this one should be the root 3 over 2. Okay, so whatever one is bigger is the root 3 over 2. Okay, so you can kind of remember that they use these numbers, but they flip, and then you can just think about the angle, which one would have a higher y value or a bigger x value. So that's how I remember them. But obviously you don't have to do that if you don't want. Okay, so using triangles, we need to be careful. So it's important to think about them in standard position, because the triangles don't always give us the positive, negative. So the whether or not the angles are positive or negative. So for example, if we were looking at cosine of 2 pi by 3, okay, I'm going to draw a picture here. Okay, so 2 pi by 3, I'm going to split pi, which is from the positive x-axis to the negative x-axis, into 3 parts. Okay, so I have these 3 equal parts. So that means that 2 pi by 3 has this initial side, and then it goes up 1 and up 2. So it's going to have this as its terminal side. So when I make my triangle, okay, I know, so I'm going to use this reference angle, okay, which is going to have, so 2 pi by 3, or pi by 3, each of these are 60 degrees. Okay, this one, like this is 60 degrees, and like this is also 60 degrees. Okay, because that's 180 into 3. So my triangle that I'm going to get, let me just do it in blue. I'm going to have to use this reference triangle. Okay, this is a, it looks like this, right? So 90, this is going to be 30, and this is going to be 60. So it's my 30, 60, 90 triangle. Okay, but we need to be careful. So, I mean, you could put on the side lengths. If we use the triangle we used above, it's going to have side length 1, side length 2, and side length root 3. But we want to be careful because it's in the quadrant, so this is quadrant 1, this is quadrant 2. Okay, it's going to have a negative x value. So in fact, we should kind of think of this side as negative 1. So you want to have it, like, you want to think about the placement. Okay, so 2 pi by 3 is 120 degrees. Okay, so pi by 3 is 60 degrees. I already said that. And we know that cos of pi by 3, or cos of 60, is 1/2. Okay, so that means that cosine of 2 pi by 3, it's going to be negative 1/2. Okay, so it uses the same triangle as this one. Okay, so it's the same triangle, but the x value is negative. Which is going to make our cosine value also negative. Okay, so you want to be careful about that. The location of the terminal side in the xy plane tells you a lot about the function values. Okay, so a common thing. Okay, so if this is my xy plane. Okay, we have quadrant 1, 2, 3, and 4. So you start in the positive, and you go counterclockwise. Okay, now there's a mnemonic device people use regularly. Okay, so it's all students take calculus. Okay, so what it means, what it stands for, is it's telling you which trig functions are positive of the main three. Okay, so the main three are sine, cos, and tan. Okay, so in the first quadrant, it's telling you that they're all positive. In the second quadrant, it's saying only sine is positive. Okay, in the third quadrant, it's only tangent that's positive. And in the fourth quadrant, it's only cosine that's positive. Okay, so this tells you which of the main three are positive. Okay, you can make up your own mnemonic device if you want. The one I used was all students take calculus. Okay, that's the one I learned in high school, but you can, if you have a better one, use that. Okay, but that's what it stands for, and that's telling you where each of them is positive. So let's do another example. So what about if I want the trig values, all 6 of them, for the angle theta is negative pi by 4. Okay, so I find it always helps me to draw the picture. Okay, so here's x, here's y. So pi by 4, remember, was 45 degrees. Okay, so we want to go 45 degrees in the clockwise direction. Okay, so let's do my unit circle here. Looks something like this. Okay, and then our angle, this is our initial side, 45 degrees in this direction is going to look something like that. Okay, so here's our point, P, if you want. Okay, so we get this right triangle. You don't have to even use the unit circle if you don't want. If you do use the unit circle, then this side is length 1, and both of these sides are going to be 1 over root 2. Okay, remember the 45, 45, 90 triangle that we used earlier would look like, okay, so there's our 90, 45, 45. We said that these were both length 1 and this was length 2. Okay, but now if you make the hypotenuse 1, you have to divide everything by root 2. So that's why we get this sort of scaled down version. Okay, it doesn't matter what you use, but you need to think about where it is in the plane. Okay, so it's in quadrant 4. So this is where only cosine is positive. Okay, so we want to be careful about that. So when we're doing our trig functions, so we want sine of negative pi by 4. Okay, so if we want to use, so sine's going to be negative because only cosine's positive. And for pi by 4, it's going to be 1 over root 2, or root 2 over 2. Okay, cosine of negative pi by 4 is going to be a positive, and it was also 1 over root 2. Tangent of negative pi by 4 is going to be negative here, because this is the quadrant where only cosine is positive. And if you don't remember, you can always do sine divided by cosine. Okay, it's going to be negative 1. And then we can do the others. So cosecant of negative pi by 4 is 1 over sine, so it's going to be negative root 2, so the flip of sine. Secant of negative pi by 4 is going to be 1 over cosine, so that's positive root 2. And cotangent of negative pi by 4 is 1 over tan, so it's also negative 1. Okay, one more example, and then we'll think about the graphs here. What if I wanted to solve for the angle? So where is cosine of x equal to 1/2? Okay, so again, I want to think about the picture. Okay, so here's my unit circle. It's not very good. Okay, so this point up here is at 1. The y value is 1. So halfway up, oh, sorry, this point, x value. So cosine is the x value on our unit circle. So this point is 1, 0. So halfway, I'm talking about there's 2 points here that are going to have x value equal to 1/2. Okay, so I want to know what those angles are. So if this is my initial side, so one of them is going to be like this. So theta 1, okay, and the other one is going to go down here. So technically the angle is going to go all the way around. Okay, so I want to find there's 2 different solutions in the 360 degrees. Okay, so I want to find, so cosine x equal to 1/2. I want to figure out how to solve this. Now your calculator actually has a button. So if you want to solve for x, what you want to do is you take cosine inverse of both sides. Okay, so that's what your button looks like. Okay, so cosine inverse of cosine cancel out. So x is going to be cosine inverse of 1/2. Okay, now here's where you want to make sure that you know your mode. So your calculator switches between degrees and radians. So you want to make sure you know what one you're in. If you're in degree mode, it's going to give you 60 degrees as your answer. Okay, if you're in radian mode, it's going to give you a decimal that doesn't look like anything. Okay, it's an infinite non-repeating decimal. So it's better when you're doing the inverse to be in degree mode because you might get a nice degree. Okay, 60 degrees happens to be pi by 3. Okay, so then we can convert to radians because we normally like our answer in radians. Okay, but now we need to be clever. So this is only one solution. So your calculator is only smart enough to give you 1. But for sine and cosine, there's often 2. So if you think about the picture, okay, the x value of 1/2 is going to happen up here. It's also going to happen down here because they both have the same x coordinate. And they're going to intersect the circle in different ways. So to find your other solution, you could realize that your angle, so theta 2, is equivalent to negative theta 1, so negative 60 degrees. So you could write it as negative pi by 3. Or it's coterminal to 5 pi by 3. Okay, which is actually going to be 300 degrees, right? It's 360 minus 60. Okay, so you could use either. Okay, now this didn't give us so these would be the only 2 solutions between 0 and 360. Well, if I don't include this negative one. Okay, if we use this angle. But there's actually infinitely many solutions. Okay, so all solutions are, so you want to give them as multiples of your original. So for instance, okay, this theta 1, okay, so that's 60 degrees, right? But I could go all the way around and then stop at the same terminal side. That's going to be another solution. It's going to have the same cos value. So what I can do is I can take my angle, which is pi by 3, and I can add 2 pi to it. In fact, I can add any multiple of 2 pi, okay, where k is an integer. So if you want to do this in degrees, it's going to look like 60 degrees plus 360 degrees times k. So I have to do a full rotation. Okay, now I want to do this for my other one as well. So it's 5 pi by 3 plus 2 pi times k, or in degrees, it's 300 degrees plus plus 360 k, where k is any integer. So it has to be an integer, but it could be positive or negative. Okay, so we could do negative rotations or positive rotations. We just need to do full rotations. So these ones are going to give all the angles that have this as their terminal side. Okay, this is going to give all the angles that have this as its terminal side. Okay, so that's how we'd want to give all the solutions. Okay, quickly, what do these graphs look like? So I'm going to space them out. Okay, so every 4, 1, 2, 3, 4. So this is pi, 1, 2, 3, 4. This is 2 pi. 1, 2, 3, 4. So negative pi, etc. And then I'll make maybe this is 1. No, let's go up 4 maybe. So 1, 1, 2, 3, 4, and negative 1. So when I'm graphing sine, so we know that sine of 0 is 0. When I get to 90 degrees, or pi by 2, that's when sine is the biggest, okay, which has value 1. When I'm pi, that's 180 degrees, the y value goes back to 0. 3 pi by 2, the y value is the smallest, okay, it goes to negative 1. And at 2 pi, it's back to 0. Same thing happens over here. Okay, so at negative 2 pi, etc. So what you get, whoops, I did this wrong. I missed one. This is when it's the smallest. Negative pi, it's back. And here it's back up. Okay, so you get a graph that has this sort of shape. Oops. Okay, and it repeats every 2 pi. On every interval that's length 2 pi, is you get a full period. Okay, similarly for cosine. So here's pi, and here's 2 pi. So now at 0, okay, cosine is at 1. At pi by 2 is when it's at 0, and at pi is at negative 1. Okay, and then it goes back to 0, and then at 2 pi, it's back up to 1 again. So every multiple, every half multiple, we're at 0. Okay, so you get a very similar looking graph, just shifted over a bit. Okay, so it looks like that. So that's for cosine. Again, repeats every 2 pi. So that's the period. Maybe I should say this is 1 and minus 1. Okay, for tan, it's a little bit different. Okay, so tan is sine x over cos x. So that means that tan doesn't exist anywhere cosine x is 0. So we're going to get asymptotes at pi by 2. Okay, 3 pi by 2, negative pi by 2, negative 3 pi by 2, okay, etc. So these are all asymptotes. When sine is 0, we're going to get a 0. Okay, so tan is 0 at 0. It's 0 at pi. It's 0 at negative pi. It's 0 at 2 pi. Okay, so this one is pi and 2 pi. Okay, and then when I am between 0 and pi, or pi by 2, the tan value is positive. Okay, but we're dividing by, as we approach, maybe I should write this. So the limit as we approach pi by 2 from the left, so as we're coming this way, of sine x over cos x, okay, so the cosine value, sine is going to 1, okay, and the cosine value is going to 0, but on the positive side. So that means that this is going to positive infinity. So what you get is something that looks like that. Okay, now if we approach negative pi by 2 from the right, okay, the sine values sine's going to so we're negative. Yeah, okay, so sine's going to -1, but cosine is still going to 0 in the positive sense. Okay, so here we go to negative infinity. Okay, so you get something like this. And in fact, that shape just repeats over and over again. For tangent. Okay, so this one repeats every pi. Okay, so notice that this interval here is length pi, because it goes from negative pi by 2 to pi by 2. Okay, so it just has interval length pi. So those are the basic graphs. You can find the other graphs by doing 1 over these graphs. These are the main ones that you should sort of have an idea of what they look like and how to compute values for. So these are the 3 most important trig functions.